Wi-Fi. It's everywhere, right? It's this invisible force that powers pretty much our entire connected lives, our work, our entertainment, everything. We completely rely on it, but let's be honest, we rarely stop to think about how it actually works, or more importantly, how secure it really is.
So, I'll ask you straight up, how secure is the network you're on right this second? Are you positive no one's listening in? Well, in this explainer, we're going to decode the real threats to your Wi-Fi and build a rock-solid defense. So here's the plan. We'll start with the basics of how Wi-Fi signals actually talk to each other. Then we'll look for the cracks in the armor where attackers love to sneak in. We're going to dissect a few common attacks, build our digital defense toolkit, and then map out a game plan for what to do if a breach ever actually happens. Look, you can't defend a castle if you don't understand its walls and its gates. It's the exact same thing for our digital world. So let's kick things off with the absolute basics of how Wi-Fi really works. Okay, so every single Wi-Fi network has two key names. The first is the SSID. That's the friendly name you see in your list, like coffee shop _ Wi-Fi. Think of it as the name of a building. The BSSID, though, is the unique hardware address of the router itself. It's more like the building's specific street address. Not very friendly, but totally unique in the world. Now, Wi-Fi communication isn't just one big blob of data. It's all neatly packaged into 3 different types of what we call frames. First, you've got management frames. These handle the initial handshake, finding and connecting to a network. Then there are control frames, which act kind of like traffic cops, making sure data flows smoothly. And finally, you have the data frames. This is the good stuff. The web page, the video, the email you're actually sending. All 3 have to work together. This right here is an absolutely crucial distinction. Authentication is all about proving you have the right to get on the network. It's the bouncer at the club checking your ID. It's the key to your front door. Encryption, on the other hand, is what happens after you're inside. It scrambles all your conversations so that if someone was listening in, all they'd hear is total nonsense. You need both to be secure, no question. All right, so now that we've got the basics down, let's talk about where things can go wrong. No system is perfect, right? And Wi-Fi has its share of little cracks and weaknesses that attackers are just waiting to take advantage of. And as you can see, security isn't just one thing. An attacker has a whole menu of options. They might go after a fundamental weakness in the Wi-Fi protocol itself, or maybe just a simple mistake you made, like using a weak password. They could even trick you into giving up info or find a bug in your router's software. Every single one of these is a potential way in. So what do these attacks actually look like out in the wild? Let's roll up our sleeves and dissect a few of the most common tricks hackers use to get into wireless networks. First up is a classic called the evil twin. Seriously, imagine a scammer sets up a fake ATM that looks exactly like a real one right next to it. That's this attack. A hacker creates a fake Wi-Fi network with the same name as a real one, like airport _free _ Wi-Fi, and they just wait for your phone to connect to their trap instead. And once you're connected to their evil twin, they can just sit in the middle and watch everything you do online. Your passwords, your emails, you name it. It works because we're just trained to trust familiar network names. Your best defense is a 1-2 punch. First, always use a VPN on public Wi-Fi. Second, go into your settings and turn off Auto Connect. It forces you to make a conscious choice. All right, our next attack method is basically digital eavesdropping. Whenever your device connects to a password-protected network, it does this little secret handshake to prove it knows the password. Well, attackers have tools that can literally record that handshake right out of the air. Now, here's the really clever part. They take that recording of the handshake and go home. On their own powerful computer, they just start guessing your password, millions of guesses a second. The whole attack relies on you having a weak password. A really long, complicated password makes their job way harder. But you know what's even better? Using the modern WPA3 security standard, because it's literally designed to make this exact kind of offline attack impossible. This next one is less about stealing your data and more about just pure chaos. A deauthentication attack is kind of like a hacker faking the bouncer's voice and yelling, "Everybody out" in a crowded club. They send out fake management frames that basically tell your device, "Nope, you've been kicked off the network." So why would they do this? Well, it's often step 1 of a bigger attack. They might kick you off just so they can force you to reconnect and capture that new handshake we just talked about. It works because in older Wi-Fi, those management frames weren't protected.
The modern fix is something called Protected Management Frames, or PMF. You should definitely check your router's advanced settings and turn it on if you can.
As you can probably tell from all these different attacks, there is no single magic bullet. There's no one thing you can do to be perfectly safe. As the source material says, defenses must therefore be layered. You need multiple levels of protection, all working together. So let's flip the script. Enough about the bad guys, let's talk defense. Let's get into the practical, real-world steps you can take right now to build up those layers and make your own network a much harder target. Honestly, the single biggest security upgrade you can make is moving to WPA3. WPA2 has been the standard for years, but we just saw how it's vulnerable to those offline password cracking attacks. WPA3 completely changes the game. It makes those offline attacks practically impossible. If your router and your devices support it, you should absolutely be using it. Okay, beyond just WPA3, here's a quick hit checklist. First, segment your networks. Have one for guests, one for your smart home gadgets, and one for your main computers. That way, if one gets breached, the others are safe. Obvious one, but change the default admin password on your router. Also, disable WPS. That push button thing is a known security risk. And finally, just like your computer, your router needs updates. Keep that firmware current.
But what if the worst happens? What if, despite everything, you suspect your network has been compromised? The first rule is don't panic. Panic is not a strategy. What you need is a calm, logical plan.
Here it is, your 6-step response plan. 1. Isolate. Just shut down the Wi-Fi. Cut off the attacker's access. 2. Rotate credentials. Change every single relevant password immediately. 3. Collect evidence. Save any logs from your router if you can. 4. Search for rogues. Physically look for any weird devices plugged into your network that you don't recognize. 5. Scan endpoints. Run malware scans on all your computers. And finally, 6. When the dust settles, review and reconfigure. Figure out how they got in and plug that hole for good.
So let's bring it all home. Here are the core ideas to remember. Use WPA3 if you can. Use a strong, unique password. Always keep your router's software up to date. Use a VPN on any network that isn't yours. And maybe most importantly, just train yourself to have a security mindset. Learn to spot when something just feels off. Because at the end of the day, your Wi-Fi network isn't just a utility. It is the digital front door to your entire life. So the real question is, have you checked to make sure it's locked?